Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of x to the power of 6 is equal to 144. Now, the first thing I'm going to do is I'm going to take the power of 6 on both sides. So now I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m times n, m and n, these two are interchangeable, meaning this is the same thing as a to the power of n times n. And if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m, this can equal a to the power of n to the power of m. And all this means that a to the power of m to the power of n is equal to a to the power of n to the power of m. So these two are the same thing. So in this case, I have x to the power of x to the power of 6 to the power of 6. And we can think of x to the power of 6 in this case as m and 6 as n. So I'm going to simply switch these two places. So now I have x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal y. So now I have y to the power of y is equal to 144 to the power of 6. And now 144 is the same thing as 12 to the power of 2. So now I have y to the power of y is equal to 12 to the power of 2 to the power of 6. Now remember, if I have something from a to the power of m to the power of n, this is equal to a to the power of m times n. So 12 to the power of 2 to the power of 6, that's going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. Now, if I have something from a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 12. Now remember how we set x to the power of 6 equal to y. So if x to the power of 6 is equal to y, and y is equal to 12, this means that x to the power of 6 is equal to 12. So now, I'm going to be taking the power of 1/6 on both sides. So I have x to the power of 6 to the power of 1/6 is equal to 12 to the power of 1/6. Now 6 and 1/6 these two cancel out. So now I'm left with x is equal to 12 to the power of 1/6. And this is the same thing as the 6th root of 12. So this is my answer. Alright, so I have x to the power of x to the power of 2 is equal to 16. Now the first thing I'm going to do is I'm going to take the power of 2 on both sides. So now I have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. Now, if I have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. However, in this case, m and n are interchangeable, meaning this is also equal to a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m, this is going to equal a to the power of n to the power of m. So to simplify all of this, a to the power of m to the power of n is equal to a to the power of n to the power of m. So these two are equal. So right here, we have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. And in this case, we can think of x to the power of 2 as m and 2 as n. So now we can switch these two places. So now we have x to the power of 2 to the power of x to the power of 2 is equal to 16 to the power of 2. So now, 16, this is the same thing as 4 to the power of 2. So now I have x to the power of 2 to the power of x to the power of 2 is equal to 4 to the power of 2 to the power of 2. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 4 to the power of 2 to the power of 2, that's going to equal 4 to the power of 2 times 2, which is equal to 4 to the power of 4. Now I'm going to let x to the power of 2 equal y. So now I have y to the power of y is equal to 4 to the power of 4. Now if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is going to equal 4. Now remember how we set x to the power of 2 equal y. So now I have x to the power of 2 is equal to 4. So now to solve this, all I have to do is I'm going to simply take the square root on both sides. So these two cancel out. Now I'm left with x is equal to square root of 4. Now the square root of 4 has two solutions. I have positive or negative 2. So these are my two solutions to this problem. Alright, so I have 4 to the power of x minus 2 to the power of x is equal to 1. So now 4 here, I'm going to rewrite as 2 to the power of 2 to the power of x minus 2 to the power of x is equal to 1. So I simply just substitute in 2 to the power of 2 for 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n are interchangeable, meaning this is also equal to a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we can think of 2 as m and x as n. So now if I switch these two places, I get 2 to the power of x to the power of 2. Now I have minus 2 to the power of x is equal to 1. So now I'm going to subtract both sides by 1. These two cancel out. Now I'm left with 2 to the power of x to the power of 2 minus 2 to the power of x minus 1 is equal to 0. Now I'm going to let y equal 2 to the power of x. So now I have y squared minus y minus 1 is equal to 0. So now to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now I have negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So now this is equal to 1 plus or minus the square root of 1 plus 4 all over 2 times 1 is 2. And now this is equal to 1 plus or minus the square root of 5 over 2. So now this gives me two solutions. I have 1 plus the square root of 5 over 2, and I have 1 minus the square root of 5 over 2. However, this is the value of y. Remember that we set y equal to 2 to the power of x. So now, let's first start with if y is equal to 1 plus the square root of 5 over 2. So we know that y is equal to 2 to the power of x. So if these two are equal to each other, then we have 2 to the power of x is equal to 1 plus the square root of 5 over 2. So now, to solve this, I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So in this case, for log 2 to the power of x, I can move x to the front. So this is going to equal x times log 2, which is equal to 1 plus the square root of 5 over 2. It's going to equal log 1 plus the square root of 5 over 2. Now, if I divide both sides by log 2, these two cancel out, and I'm left with x is equal to log 1 plus the square root of 5 over 2 over log 2. So now this is the same thing as log base 2 of 1 plus the square root of 5 over 2. Because if I have something in the form log a over log b, this is simply equal to log base b of a. So this is my solution. Now, remember how there was another solution. If y is equal to 1 minus square root of 5. So if this is true, then I have 2 to the power of x is equal to 1 minus the square root of 5 over 2. However, 1 minus the square root of 5, that's going to be negative. And this means that 2 to the power of x has to equal a negative number. And you can't take the power of a positive number and make it a negative. So, meaning this has no solution. So our only solution is x is equal to log base 2 of 1 plus the square root of 5 over 2. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 1 divided by x is equal to 27 to the power of x. Now, what I'm first going to do is I'm going to take the power of 1 over x on both sides. So now we have 1 over x to the power of 1 over x is equal to 27 to the power of x to the power of 1 over x. Now, if we have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So as you can see here, we have 27 to the power of x to the power of 1 over x. This would equal 27 to the power of x times 1 over x. When for x times 1 over x, these x's simply cancel out, and we are simply left with 1. So this would be 1 over x to the power of 1 over x is equal to 27 to the power of 1. Now 27, this is the same thing as 3 to the power of 3. So now we have 1 over x to the power of 1 over x is equal to 3 to the power of 3. Now, if we have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So as you can see here, 1 over x is a in this case, and 3 is b, meaning 1 over x is equal to 3. Now, if I multiply both sides by x, these two cancel out, and I get 1 is equal to 3x. Now if I divide by both sides by 3, These two cancel out, and I get x is equal to 1 over 3. So this is our answer. Now, to check, let's plug in x in this equation. So now we have 1 over 3 is equal to 27 to the power of 1 over 3. Now, 27 to the power of 1 over 3 is the same thing as the cube root of 27. And the cube root of 27 is 3. So now we have 3 is equal to, now 1 over 3 is the same thing as 3. So 3 equals 3, because this is right, we know that our solution is right.